Hi everyone, this is Manohar Sherry. In this video, I want to discuss about how to find out the RMS value of alternating current. Before going to that topic, I want to tell you why AC quantities are expressed in RMS values. So here I have written the formulas to calculate the power consumed by the resistor in DC circuit and AC circuit. So if you see the power formulas in DC circuits, P equals to V into I, P equals to I square into R, P equals to V square by R. In AC, when AC voltage is applied across the resistor, if you want to calculate the average power consumed by the resistor, can be found out by using these formulas. So here, where Vm is the peak voltage and where Im is the peak current and R is the resistance. If you compare these two formulas, they are not same here. So what is the need to express these AC quantities in RMS values? The need is, so by finding these RMS values, we will express the AC power as like DC power. So this is the reason behind expressing the AC values in RMS values. Okay, so let's discuss the concept of the RMS value. So here I have written that RMS value of AC defined based on heating effect. So how to understand this statement? Here I have drawn two circuits. So one is DC circuit and one is AC circuit. Here DC voltage source and here it is AC voltage source. So here I have connected DC voltage source across the resistor, and when I have connected this voltage source, current I start flowing in this resistor, and I am operating the circuit over a time period T. So due to this, the resistor is dissipating some amount of electrical energy into heat energy. So let it be K joules. So in time T, so this resistor R is dissipating the electrical energy into heat energy. The same resistor I am taking here and I am connecting that resistor now with an AC voltage source, and now I am operating the circuit for the same time T. So how to define the RMS value of alternating current here? I told that RMS value of alternating current depends upon the heating effect. So I can define like this. So the amount of AC current required to produce the same amount of heat energy as like here in the same time as like here and in the same resistance is known as RMS value of alternating current. I am telling one more time. So the amount of current required to flow in the circuit to produce the same amount of heat energy as like in a DC circuit when the same resistance is connected. Okay, so this is about the concept of RMS value of alternating current. So let's derive the mathematical expression for the RMS value. So what is the full form of RMS value? It is root mean square value. So how to find out what is the formula to calculate the RMS value? For example, I want to find out the RMS value for the I of t. So I of t is nothing but instantaneous current. So when AC voltage applied across the resistor, so what is the current flowing through the resistor? I of t equals to Im into sin omega t. So we know that where I of t is instantaneous current, Im is peak current and omega is the angular frequency where t is time. I want to find out the RMS value for alternating current. So you just see the full form of RMS value. Here, what is the term here? It is squaring. So first you do square for which you want to find out the RMS value. So if you do square, then you will get I square of t into Im square sin square omega t. So after completion of square, then do or find mean. So what is mean by mean? So mean is nothing but average value. So if a continuous function is given, so you know how to find out the average value. So the formula is f average equals to 1 by t integral 0 to t f of t dt. So here I want to find out the average value for this function, which is I square of t. So the formula now, average of I square of t is going to be 1 by t integral 0 to t sin square omega t into dt. So now I have average. After that, So you just see here root is there, then you take the root for this. If you take the root for this, then you will get the RMS value of I of t. So which one I will write as RMS as like this. So you just take the square root for this, then 1 by t integral, so 0 to t I of t square into dt. So here I forgot to write Im square, students. Okay, so Im square sin square omega t. So this is the formula to calculate for IRMS. Similarly, I want to find out the RMS value for the alternating voltage. Then first you write that formula. Then V of t equals to Vm sin omega t. So what you have to do? First you do square. Then V square of t equals to Vm square sin square omega t. So after doing square, you find mean, which is nothing but average. Then average of V square of t is going to be, so 1 by t. So here V of t is also continuous function, 0 to t. So Vm square sin square omega t into dt. Okay. So after finding the average, then you take the square root. Then so VRMS is going to be square root of, so 1 by t integral 0 to t V of t square into dt. So this is how you have to find out the RMS value of voltage. Okay, so this is the basic formula, but here we need to find out the integral V square of t dt, and we should take the square root for that. So all these things we need to do here. So let's do all these things. Okay, first I am going to find out the RMS value of alternating current. Then, so what is the formula for RMS value of alternating current? So we know that I of t equals to Im into sin omega t. So write the IRMS. So IRMS is going to be, so just take the square of first I square, then take the mean, that is 1 by t integral, so 0 to t into dt. So then take the square root. If you take the square root, so this is going to be the formula. So let's substitute the values. So here what is I square of t? So I square of t is Im square sin square omega t. So this is the value of I square of t, but here we need to integrate this I square of t, but here we don't have direct formula for integrating sin square omega t. So I will change this into other trigonometric function. So we know that, so cos 2 omega t is equals to, so 1 minus 2 sin square omega t. So I'll write sin square omega t as sin square omega t equals to, so 1 minus cos 2 omega t by 2. So now I have the sin square omega t value. So you substitute this value here. Then I square of t will becomes Im square by 2 into 1 minus cos 2 omega t. So now I have the value of I square of t, which is nothing but Im square by 2 into 1 minus cos 2 omega t. So substitute this value in the formula of IRMS. So if you substitute, the IRMS value is going to be IRMS equals to 1 by t integral 0 to t. So I square of t, that is Im square by 2 1 minus cos 2 omega t into dt. So we have to take the square root. Then, so here Im square by 2 is a constant. You can take it out from the integration. So while you are doing integration, so if you take it out from the integration, it can be written as Im square by 2t integral 0 to t 1 minus cos 2 omega t into dt. So you have to take square root. Okay students, now let's integrate this term. So here 1 minus cos 2 omega t. So then I will multiply. If I multiply, so the equation or the IRMS value will becomes like this. So Im square by 2t integral 0 to t dt. 1 into dt is dt minus, so cos 2 omega t into dt. So integral, so 0 to t cos 2 omega t into dt. So we have to take square root. And then IRMS. So integrate. What is the integral dt? It is t. So what is the integral cos 2 omega t dt? It will be sin 2 omega t by 2 omega. So then Im square by 2t. So integral dt will be small t and 0 to t. So here lower limit is 0 and upper limit is capital T minus, if you integrate this cos 2 omega t dt, the answer will be sin 2 omega t by 2 omega. So limits are here 0 to t. So lower limit is 0 and upper limit is capital T. So again take the square root. Okay. So here 1 by 2 omega is a constant. So before substituting the limits, you can take it out from the brackets, and here you can substitute the limits. Then IRMS is going to be Im square by 2t. So upper limit minus lower limit. So which is nothing but capital T minus 0 minus 1 by 2 omega. So I have taken this 1 by 2 omega out from the limits. Then substitute the limits. If you substitute the limit, upper limit is sin 2 omega t minus, if you substitute the lower limit 0, that is sin 2 omega into 0. So sin 2 omega into 0 will be sin 0. So directly I am writing its value as sin 0. So we have to take square root. Then we know that, okay, let's simplify this. Then IRMS is going to be Im square by 2t. So t minus 0, t minus 1 by 2 omega. Here sin 2 omega t minus sin 0. Sin 0 value is 0 only. So sin 2 omega t minus means sin into 2 in the place of omega. We know the value of omega, so which is nothing but 2 pi by t. Substitute the value of omega, that is 2 pi by t into t. So minus 0, so you can no need to write that here. So we have to take the square root. Then IRMS is going to be, so this t and this t will be gets cancelled. Here we are going to have sin 4 pi. So write that value. So Im square by 2t into t minus 1 by 2 omega into sin 4 pi. What is the sin 4 pi value? 0. Then 1 by 2 omega into 0, 0. Then what is left here? Only IRMS equals to Im square by 2t into t is left. Then so this t and this t gets cancelled. Then you will get like this. So Im square by 2. So whose value is nothing but Im by root 2. Then IRMS is equals to Im by root 2. Okay. So we have calculated the value of IRMS. So which is nothing but Im by root 2, where Im is the peak value of current. Similarly, if you calculate the VRMS, so whose value is Vm by root 2. So we have calculated IRMS equals to Im by root 2. Similarly, if you calculate for VRMS, so you will get VRMS as Vm by root 2. So in the beginning of this video, I told that so the purpose behind expressing or introducing the RMS values is to express AC powers like DC power. So what is the AC power we have calculated previously? That is, first formula is P average is Vm into Im by 2. So this can be written as, so Vm by root 2 into Im by root 2. So which can be written as, so Vm by root is VRMS and Im by root is IRMS. So VRMS into IRMS. So that is the formula for P average. So in case of DC, so what is the formula for power calculation? That is V into I. So if you can see, the values are, the formulas are same, but in AC here voltage means RMS voltage, current means RMS current, voltage into current. Similarly, what is another formula we have written? P average equals to half into Im square R. So this is how we got in average power. So this can be written as Im by root 2 whole square into R. So this can be written as Im by root 2 IRMS, then IRMS square into R. So in case of DC, what is this formula? So that is power equals to, so I square into R. Similarly, so if you write for other formula, so that is V average equals to, you will get as V square RMS by R you will get. So in case of DC, it is going to be P equals to V square by R. So now we have expressed the AC powers as like DC powers. Okay, thank you students.